Fantastic. Right. So let me tell you what's my objective today. My objective today is basically to introduce you to uh, the very important, or rather the most important application of Python, of why Python is so popular today. Yes, Python is the number one language for automation. Python is the number one language now for testing, that is automated testing. Also, Python probably would become or come to the number one position maybe in the next 1 or 2 years with respect to embedded programming also, because Python is coming out with huge number of libraries for embedded programming, for which right now C, C++, and Java are holding the number one positions. But probably it will offset them in the next 2 years, because the speed से development हो रही है libraries की Python में, वो phenomenal है. उस स्पीड का 1/10 से भी न्यू डेवलपमेंट नहीं हो रहा है in the libraries of Java. But C++ is going to go nowhere, because effectively anything which you write in Python is convertible into actually a C++. But to be very honest, the Python compiler actually converts your code into a C++ code and actually then runs it on the low-level platform. Therefore, it is a little slow. So Python will replace Java in that space also. And everybody attending the session knows very well that Python is number one when it comes to, or rather is a monopoly language when it comes to machine learning, data science, and AI. You will not think of doing machine learning, solving a research project, or probably solving a research problem, or solving problem of a real client or an industry by using R, or by using some tool like SAS, or by using some tool like Rapid Miner. See, all these tools are good for the purpose of doing data analytics and getting information out of data or making a prototype model. But ultimately, when you actually want to solve a problem and write a code to actually take the data from the client in real time and actually solve it, you have to use some language. And in that situation, many people ask me that instead of learning so much of programming and from non-programming background, I would prefer to learn tools and enter the data science industry. I don't say there is always a shortcut and there is a long cut. Shortcut will allow you to enter the industry, but will keep you in the industry for a very short period of time. And then you will have to go on learning new tools probably every 2 years. There is no end to it. I am not saying you shouldn't learn the tools, but that does not mean that you shouldn't learn one programming language. So in parallel, you should have knowledge of one programming language vis-a-vis the respect to the tools. Right. So what are the broad steps in any machine learning problem solving? Any machine learning problem solving. So if any one of you is probably doing a research project as a part of the PhD course, many of you would already be doctorates. So you probably could also be taking up some consultancy projects for your institution. So in that particular case, or your institution will tell you that, come on, you're a doctorate now, come on, pick up some consultancy projects and make a revenue generation model for the institution, because institution maybe 4 or 5 years from now will not work traditionally the way they are working. So this is a kind of a piece of, you can take it as an advice or as an alert message, which how you get an alert message on your pop-up box on your browser. So you can take it as an alert message. In the next 3 or 4 or 5 years, you will not expect institutions to weigh the way they are working. They will not be able to survive. So either they will have to shut down, or they will have to, think of starting something at a very high qualitative and at an industry level. So I would look forward that our company, Swin Consultant, is already in tie-up with SPIT, in tie-up with NMIMS University, and in tie-up with Upgrad and Simply Learn, which are worldwide edtech companies. So we would be more than happy to tie up with your institutions as well, to start a kind of a certification program in the AI space for your students, for your teachers, so that for all outsiders, so that that becomes a revenue generation model for your institution. Plus, it also adds value as a skill. See, you're giving paper-based degree to your students, and that's the reason students, all of them are not getting placed. Some of them are getting placed, and for some institutions, the placement is as low as 20%, as low as 15, 20%. Effective on-ground reality, They may state 40, 50, 60%, but on ground reality 20%. So people have started actually earning a decent salary. So, how do you actually improve on that? I'm not saying that you should learn only AI, but there are a lot of technologies which you deal with. But AI is the futuristic technology. So you will say that our institution is started with a course called data science. So that makes it more of a valid reason that you should have basically lab work where we could actually make students train on simple to intermediate to complex real-time problem solving. Of course, that comes as an additional cost to the institution, but the institution should think that when they can hire teachers and pay them a few lakhs of salary per annum, they can also hire a company like Swen Consultants and probably pay them that one teacher's or two teachers' salary and actually pass on that load of practical down to our company. So our company is going to do that best. So you can actually, so if somebody over here who's listening to me on this FDP program, I had told this in the SPIT FDP third program also. Malik ma'am was the witness to it because she was there as a part of the program. And today, Dr. Rathore sir, who's my very good friend, is also going to be coming in the afternoon. We were speaking 2 days ago on some other topic. So he told that, Rocky, aap morning mein ho, afternoon I'm coming. And I told, fantastic, sir. Malik ma'am is a very beautiful coordinator. She coordinates things very well. And, so we were just discussing about it that of how institutions is in need of the hour. So even the top institutions are finding difficult to, because he just called me to thank me that, Rocky, so many of our students have got wonderful internships. Even in this COVID time, they're like, they have taken your name. They have taken your name, Rocky, because of Rocky sir's internships and lab work training, it has really helped us. So I'm talking of internships of people getting in companies like Microsoft, Phone Pay. These companies are paying to interns, third year students, interns. They are paying a stipend of anywhere between 50,000 to 60,000 rupees. This is a stipend per month, stipend being paid to third year students. This is as high as that. Of course, average is 20, 25,000, but then there are some companies with 50,000 rupees also. Why they liked it? Because they said that after all things are in place, theory part is in place, everybody talks about this theory, okay, skill-based work. So if there is skill-based work, it definitely adds value. So try and think of that. In fact, the best of the institutions have tied up, Upgrad and Simply Learn and NMIS University and SPIT, which already have 100% placements, they tie up with Swen Consultants. But not colleges where my friend Bhuma Devi works like KC College, and not where Mayura probably works or where Vismita works. Why not? Or where Sabu Siddiq colleges. So, you should think in a little broader perspective, because you will be in a tough time to get students, friends, because you will have, after 3 years, students actually directly enrolling for a graduation program with Upgrad and getting certified, 100% placements, and certified from a foreign university like Purdue or Indiana University or Triple IT Bangalore or Triple IT Hyderabad, because they're all offering the certifications. I'm a part of one of the course content development team with Upgrad, which is working in collaboration with one foreign university, then Tech Mahindra company from where Sonali had come to give the topic. So there is a big team of 8 people who are doing the entire content development of the entire course. I'm one of them. So I can understand that after 1 year, if you have a 3-year graduation program and with people working from home and studying from home, so IT colleges will have trouble. Anyway, electronics, civil, and all this is in a difficult position. So, you need to understand an overall thing that you need to send on a LinkedIn message to me, connect up your LinkedIn, request. First, you need to give a description. Like, for example, Shakil is asking for some details. No, Shakil is not like this. It's all customized. First, we have to know about you. That means about your institution. What is the background of the institution? What do you foresee? What's your vision in terms of budget, in terms of the vision for your students? And so we don't have training programs which are short term. Our training programs go for 3 years, which are customized to integrate your lab work with us. So what we do is that we tell that rearrange your teacher's portfolio in such a way that we are put as a consultant or as a faculty to your payrolls, and we take up your practical load. So one of the practical loads taken first semester teaches the students skill-based work, and due to which students are at benefit, colleges at benefit, because they are saving cost. Instead of paying a 12 lakh rupee salary to a teacher, they have probably paid it to a company which is taking care of about 2 practicals or one practical per class of theirs, and every student learns it. Of electronics, of civil, of mechanical, of computers. Let everybody learn, no? Because AI is applicable to everyone. It's not only applicable to computer science people. So, with that constructive and a healthy note, which I thought of giving you in the last day, I now move further. So, having looked at this particular diagram of ML, any problem of ML you get, the first part is data collection. It seems to be easy because we usually use CSV files downloaded from Kaggle and all that stuff, but trust me, this is the most difficult task. Data collection or generating data is the most difficult task because you really don't get uh, real data so easily. It comes at a premium, it comes at a cost. No company is ready to, in Indian, especially in India mentality, no company is ready to give away their data. Okay, once data is come to you, naturally, data would have lots of missing values, lots of nonsense. Example, somebody's name is written as James Bond 007. Now, can somebody's name really be James Bond 007? So, obviously, when you have the data, you will have to prepare it so that it can be used for a machine learning model to learn it. Model fitting means a machine learning model is being used to fit over the data. It's learning your data. So once data is prepared, you give it to a machine learning model. Now, once machine learning model has learned the data, it's like a kid who has gone to, has picked up some guides. School kid picked up some guides, okay, and has learned everything there. So once everything is learned by the child, what will you? How will you test it? Sir, I will take a small class test. Correct. So you will take a small class test of your own child to know whether he or she has learned it or not, isn't it? So same way, if machine learning model has been fit or has learned the data, then you should check it now. So how will you check it? You will evaluate it. So model evaluation is done to check whether the model is performing to the minimum expected performance metrics or not. Let's say minimum expected accuracy or not. And if it is, cool, tick mark. The model is good. Please let's deploy it by a DevOps team and start using it. But if it is not, and the model evaluation is not giving you the required performance metrics, then you should go for hyper parameter tuning. That means tuning or changing the parameters of your model to make it better. And this phase will go on 4 to 5, 5 to 4, 4 to 5, 5 to 4. This will go on till you don't get satisfactory performance. Only then this will stop. Okay. So, as the notebook has already been given to your friends, so you already have this reading part with you. An experienced ML engineer, because usually you see designations opening up in companies as junior data scientist. Data scientist or junior data scientists don't do much coding. Their work is more, most of the time their work is here only. These two phases. A junior data scientist most of the times does the work in these two phases, only step 1 and step 2. वो इधर ही पड़ा रहता है. Data collection, data exploration, data preparation, data wrangling, data cleaning. This is what he does. Step 1 and 2. An ML engineer does the work of 3, 4, 5. 3, 4, 5. AI engineer does everything. Or AI engineer has knowledge of all the phases very well in terms of project designing as well as in terms of coding. So you should aim to become an AI engineer, not junior data scientist or data scientist. No. Data scientist, junior data scientist is only these two roles. And as the technology is progressing, software development and web development will completely be automated by using AI, where you will only do drag and drop and the code will automatically be generated. So simply writing a code in web or in Java will probably be replaced completely. Even in Python also your code will get replaced because of drag and drop tools. So those will generate. But then there is a need to generate those tools. No? कोई तो कोड करेगा वो tools को. That's where an AI engineer will really help, because an ML engineer, AI engineer will know all this stuff very well. But the first and fourth primary thing is that you should know Python very well. That's what the objective of the workshop was. That was a vision statement of Malik ma'am with FDP 1, 2, and 3, and her team, Lubna and Samreen. Okay. So, moving further, so what do I say here is that preparing the data, training the model, packaging the model, maybe in a pickle file, validating the model by a different team, then giving to DevOps team to deploy the model, and the ML and the DevOps team both monitoring the model. that is it working properly, is it not consuming too much of resources, is it not taking too much of time to run, वगैरह वगैरह. Okay, so now how do I demonstrate this to you? मैंने बोल तो दिया आपको कि ये सब phases होते हैं, एक pipeline ऐसी बनती है, prove कैसे करूँ आपको मैं? You would have noticed my nature that whatever I speak in theory, I have a habit of proving it through a practical. So I'll be taking a very dummy data set called student grant recommendation. I have even mentioned it. That's a toy data set. And we'll be implementing the ML pipeline completely. And this notebook is actually an end-to-end ML problem solving, where you will see all phases. Problem may go very complex, but the phases have to remain the same. So yes, friends, I'm not taking time out to speak about different types of ML algorithms, because 2 hours doesn't permit me to do so much. But then, to be very honest, just a quick recap. आप मुझे पता है आपको सब मालूम है, but then just a quick recap. ML algorithms are of broadly two types. First is supervised, and second is unsupervised. When it comes to supervised further have two types. It could be a regression-based problem, or it could be a classification-based problem. So supervised, regression, or classification-based problem. And as regards unsupervised, we are having again two varieties here. First is clustering, which is very similar to classification, and second is association rule mining. Association rule mining. So quick example and a very simple example of regression is what we are going to whenever we look at, let's say, houses. If you go to buy a property, you always have, in a given locality, in a given big complex or big society, if 1 BHK is costing so much, 2 BHK will cost more, 3 BHK will cost even more. You know it very well, because it's a regression based problem, where in the regression based problem, you know very well that as the area in square feet increases, the price or the cost of the house will also increase. So if you have area for 500 square feet, 1000 square feet, and 1500 square feet properties, and if somebody shows you a property of 1420 square feet, you can easily find the cost of it, isn't it? Because you have a kind of a graph where you can project this here, and you can tell me what is going to be the price of the house, although you measured only 500, 1000, and 1500. So this is a regression based problem. Okay, what is going to be a classification based problem? Classification based problem would be to classify data points. Example, suppose the problem which we are going to solve right now, I think it's a classification based problem, where we are having some students, and you are supposed to tell me whether they would be offered a grant. They are PhD students who have applied to a foreign university, and in foreign university, if usually, because there are lots of universities in foreign countries which are offering PhD programs, so usually people join the PhD programs only if they are being given a grant for doing their research work. Otherwise, why should they spend money from their pockets? So they're generally doing some big research, and so they need some funding from the university. So what they are expecting is, looking at the performance of the student, some students are going to be classified in the red category and some in the black category. The people in the black category are the ones who have been given the grant, and the people in the red category are the ones who have not been given the grant, depending upon lots of parameters. Parameters could be how has there been project score, how have there been their reviews, how has there been their attendance for various conferences which they have attended, vagera, vagera, vagera. Okay, so on these basic parameters, we are judging whether the student will be given a research grant or not. Okay, so this is the kind of problem we are going to be facing today. right? So that's a very quick and brief description. Student grant recommendation is your work today. So name, student name, overall grade, obedient, research score, project score, and recommend. Now, if I look at all this from name to recommendation, these are my existing columns in the data set which we have. And I have very clearly mentioned the data set is an artificial toy data set. Now, friends, when you run your code in Colab now, this is Jupyter Notebook. Now, I'm coming to Colab now. I'm going full screen, coming to Colab. This is a Colab module that has been given to you. Okay. So, in the Colab notebook, friends, please notice that I have kept these two lines of code from Google Colab import files and files.upload. क्यों ये रखा है मैंने? Because whenever you want to work in Colab notebook, you have to upload your data set. If you don't upload the data set, then how will Colab be able to use it? Right? So you upload the data set. Now, from where you get the data set? Interesting. So I have given you the drive link here. So first, a request to all, go to this particular drive link, and download the data set. So small data set, many instructions. Data set download करने के बाद, after downloading, what you will do is, you obviously after downloading your downloads folder में वो file जाकर कहाँ बैठा होगा. Then you run this code, click on the play button, the code runs. Just a second, huh? Just wait for 10 seconds, please. Right, so I want to run this code. I click on the play button. So what's going to happen is, this is going to open a file dialog box where I can select the file which I've just downloaded. And once I select the file will get selected and will get uploaded to my Colab notebook like this. So choose files, please. I select this and I go to the path where I would have kept this file. I'm just searching in a second. And moreover, I have to finish this work in 30 seconds because 30 seconds is the time for which this guy holds up. Student records, I've got the file. I say open, and in 5 seconds, the file will get uploaded. And see, he says student underscore records.csv has got saved on your Colab notebook. Now, thereafter, we can keep bindas using it. Okay, please do this and tell me yes or ready on the chat window. Any confusion? Please ask me on audio or on the chat. Okay, so Shakil, to download a data file, you just need to go down to the Google Drive link which I have given here. Open the Google Drive link, download the file. Did you get the Google Drive link, Shakil? As you can see on my screen, you would have same in your Colab notebook also. Okay, Vismita says done. Good. Okay. So only Vismita and Mayura have said done. Why others have got held up? कुछ भी नहीं करना है, राइट? आई रिपीट वंस अगेन. ये गूगल ड्राइव का लिंक है जो कोलैब नोटबुक में दिया हुआ है विद द सिंपल इंस्ट्रक्शन डाउनलोड डेटा सेट फ्रॉम दिस लिंक. इसे सिंपल इंग्लिश क्या होगी? आपने लिंक से डेटा सेट को ओपन किया, डाउनलोड बटन क्लिक किया, डाउनलोड हो गया डेटा सेट. अब इस इस कोड सेल को आपने रन किया और जो फाइल डाउनलोड की है आपने अभी स्टूडेंट रिकॉर्ड्स डॉट सी एस पी, उसको सेलेक्ट किया. दैट्स इट. वो फाइल अपलोड हो गया आपके कोलैब पे. I'm waiting only for 30 seconds more. People have not done till now will be left because अगर आप डेटा सेट अपलोड नहीं कर पा रहे हो तो फिर आगे कैसे बढ़ोगे? जिनका हो गया वो इमीडिएटली यस कहे चैट पर मुझे, जिनका हो चुका है. विस्मिता मैयरों को छोड़ के बाकी किसने किसने किया? व्हाट अबाउट बुमा देवी? Today it seems Sonal, everybody not coming.
So this problem I have, I'm having the collab
Yeah, I
now.
understand you have the collab number, but you are executing or not with me today?
No, sir, I'm doing other work also along with this.
Oh, oh, always multitasking, always multitasking. Very nice.
What to do, sir? We
क्या
have to
कर? नहीं,
do.
I understand. I understand. Right. Okay. So Shakil, I hope you have done it. There is no acknowledgement from your side. Please be a little quick. Right. So now, friends, having downloaded the data set, our next step happens is student records.csv, where we are reading the CSV file into our Colab notebook as a data frame. So when you read a CSV file, the pandas.read CSV reads your data as a data frame. Data frame looks ditto like a table. Data frame looks like a table. You have rows and columns. The row numbers are the index numbers. By default, the index numbers are automatically given by the data frame starting from 0 going up to the nth record. Columns were already there. Column names were already there in the CSV file. So name, overall grade, obedient, research score, project score, and recommend. Now, can my FDP3 participants help me and tell me whether the column called recommend, if you compare every other column, okay, I'll not give you any hints. Which column do you think is a target variable, is the outcome? Which column do you think is the target variable or outcome? Is it research score? Is it obedience? Or is it recommended? That means recommend means yes means student has been given a research grant. No means student has not been given a research grant. So please, I'm waiting for your answer. Which column do you think is the outcome or the target variable Y? Please put it over the chat. That's right. Booma, Mayura is given perfect answers. The outcome variable here or target variable Y here is the recommendation. Absolutely. Very good, Mr. So recommend indicates here whether the outcome variable, so this indicates that if I give you a student's overall grade, how obedient he or she was, their research score in terms of how much work of research they have completed, and their project score given by the internal guide. If I can give you these 1, 2, 3, and 4 details, then your model should be able to tell me whether such a student should be recommended for a research grant or not recommended for the research grant. One very basic question I like to ask. If you look at this data set, जैसे आपको दिख रहा है स्क्रीन पर, do you see that it is having any missing values, any blanks, any nonsense value? Example, in research score there is ABC written, or in overall grade there is 2, 3 What, 235 written? No. Correct, Mayura. Very good. So there is no nonsense in this data. Therefore, the data is considered to be clean. It is already clean data. So I read this statement for all of us. Based on the data set above, we do not have any data errors or missing values. Hence, we will mainly focus on future engineering and scaling in this section. So data is not having anything which is unclean. So what will be clean? आपका घर बिल्कुल साफ लगा हुआ तो वापस थोड़ी साफ करोगे उसे. Still, post the session, if you wish to know, hey, what is unclean data, I have a video for you to make you feel and make you look, okay, what an unclean data could be. Step 3, feature extraction and engineering. So let's look at this. Let's start by extracting the existing features from the data set and the outcomes in separate variables. Note 1, features are input variables on which the ML model would be trained. Features are input variables on which the ML model would be trained, and they are always represented as capital X. Any ML problem you face, you should represent the input features by capital X. As well, any outcome label or outcome variable which you see, you should indicate it by small y. The only column which is not in the set of features would be the outcome or label. Now, because you have the outcome or label given to you in this data set, so the ML modeling which you would be doing is called as supervised learning. As I told you some time back that this 2 hours doesn't permits me to explain you all the differences between supervised and unsupervised machine learning. It's itself a topic of 2 hours. There are so much of differences. So I will not be going into that. So now let me start preparing the data. My data preparation phase is now going to start. Data collection तो नहीं करना हमें. Data has already been given to us in our hand. Preparation तो करना पड़ेगा ना. Data preparation will have lots of steps. First step is, please separate your data set into two set of columns. First set of columns will be called upon as features, and second set of columns will be called upon as outcomes. I'll tell you once again. जो columns आपके पास है data set में, उनको separate कीजिए. इसमें से आपको 1, 2, 3, 4, 5, इन 5 में से जो कॉलम्स आपको लगते हैं कि x में होने चाहिए उनको x में रखिए. And recurrent already discussed हो चुका है, will be going as an outcome label or a target variable y. Now one more very generic question. Will you ever decide to give a research grant or not give the research grant to a student based on his name? Do you think this kind of cultural bias is correct at a university level? Tell me, yes or no? Is the cultural bias at a university level where you have the full name of the person and from there you decide इसको हम financial aid दे या ना दे, क्या वो सही है? Confused? वापस पूछूं? मैं आपको ये कह रहा हूं कि assume there is a minority institution. There is a minority institution, and the minority institution is having the names of the students. So the students belonging to their minority or their frame of minority community definitions are being given the grant, and other deserving students are not being given the research grant. Is this correct? No, it's wrong. It's absurd. ऐसा कभी नहीं होना चाहिए. इसके लिए, if you give to an ML model the name column of a student, and if this is now today there are 8 records, tomorrow if there were 800 records, and out of that many students were the name Henry or many students were the name John, and if out of 5 Johns, if 4 Johns have got the research grant, then the ML model will learn, or rather will wrongly learn, that if the name of the student is John, he is blindly being always recommended yes. He will start mapping between this common factor of the name and this recommend yes. I again repeat this problem. See, to ML model, if you have, let's say, 800 students applying, out of which 5 students have the same name John, and unfortunately the same surname also, suppose, and out of 5 people, 4 Johns were recommended yes, then the ML model may catch this wrong relationship. This kind of a relationship, if trained on ML model, then the ML model is having not bias, it is got wrongly trained for a cultural bias. सर एमएल मॉडल को कल्चरल कैसे मालूम? एमएल मॉडल को कल्चरल नहीं मालूम, आपको तो मालूम है। आपका ये आपका बच्चा है, आप जो सिखाओगे वो सीखेगा वो। तो आप अपने बच्चे को गलत सिखा रहे हो तो वो गलत ही काम करेगा ना। यू हैव टू यूज योर ब्रेन्स, राइट? यू आर ट्रेनिंग द एमएल मॉडल, एमएल मॉडल नॉट ट्रेनिंग यू। So cultural bias is getting introduced because of this name factor. Oh my god, so what should I do? Remove the name factor, khatam. So the fields which are not relevant to the target variable should be dropped or shouldn't be taken, in other words. So as Mayura and Bhuma Devi very correctly answered on the chat. So what do I notice here is, in my feature name set, notice I have taken overall grade, obedience, research score and project score. I have not taken the name of the person. I have given you a reason. And as regards, by taking these feature names from the data frame, you made a new data frame called training features. And you took only one column called recommend and dumped it in the variable called outcome labels. I printed both for you. Have a look. The first set of data, overall grade, obedience, research score, project score. First column, second, third, fourth. 4 columns for X, that is input to the ML model, and this is the output. Initially, we will give our ML model to learn the input and the corresponding output. Means, imagine this ML model is a small girl or a boy studying in 3rd or 4th standard and at your home. So, at your home, if you have kids, if they're not very grown up, then how do you expect them to learn, or how do you teach them? Because now from last 1 year, all parents have become teachers, home teachers also, to teach their kids. They were not going to school. They will not go to school for the next 6 months also. So, as a parent, as a home class teacher, school teacher, we will teach him or her like this, ना, कि सुनो, अगर सवाल ऐसा आए आपको ऑनलाइन में, तो आपको ऐसा आंसर लिखना है। सवाल is that what are the problems faced by the Indian political system? So you need to answer like this. Identify the number of problems due to air pollution. So you have to answer like this. So what are you training him? According to the question, how you should answer. Because the same question can be asked in 2 different or 3 different ways. So you're teaching him कि ऑनलाइन में सवाल कैसे आएगा तो जवाब कैसे देना चाहिए. सो मेरा आपसे ये पूछना है, यही ट्रेनिंग अगर आप एमएल मॉडल को दोगे तो वो भी पढ़ लेगा. इफ अ स्टूडेंट्स ग्रेड इज ए, he has been obedient, he has a good research score and a good project score, then he is to be recommended by all means. Yes, simple. But if a student is having an overall grade F, he is not obedient, he has a very poor research score and pathetic project score, then he shouldn't be recommended for any research grant. No. Okay, so that's what we're doing now. But what we're doing first is, our features have to be first divided into numeric features and categorical features. Why? Okay, I'll explain this, why they have to be divided. But first, I hope you agree that these 4 columns were your features, were your X variable. And I've divided them into 2 parts. Research score and project score, yeah, they are numeric values, that's right. They are numbers, no? And I've done them in a variable called numeric feature names. But overall grade was like A plus B kind, na? ABC kind. And obedience was yes or no. Huh. So these are categorical data. Like gender, male, female, obedient, yes, no, absent, present, overall grade, all these are categorical features. So I've separated them together. Why? Because I have to process them separately. इनकी प्रोसेसिंग अलग अलग तरीकों से होती है. न्यूमेरिक फीचर्स अलग तरीके से प्रोसेस होते हैं, कैटेगोरिकल अलग तरीके से प्रोसेस होते हैं. तो इन दोनों को पहले हम प्रोसेस करेंगे, वापस मर्ज कर देंगे. अभी हमने सेपरेट किया है ना, प्रोसेस करके वापस इनको मर्ज कर देंगे. नाउ if you are having a numeric quantity, if you are having a numeric quantity, the kind of basic pre-processing that needs to be done, is the basic kind of pre-processing that needs to be done on a numeric data is called as scaling. Is called as scaling. So what is scaling? Scaling means normalizing your data. So people who know statistics, they will be familiar with the word normalize. Okay. People not aware of statistics, okay, remember the word scaling only. Now I'll tell you what scaling is and why it's necessary. Friends, suppose if I give you some YouTube video count data. So I'm giving you some YouTube videos and I want you to do some kind of prediction model over it. The first video A has been viewed for 100 times. The second video B is viewed for 1000 times. Third, 10,000 or some figure around 10,000. And the fourth, D, some figure around 1 lakh. See, when I say 1 lakh, I don't mean to say exactly 1 lakh. It could be 1 lakh 50,000. It could be 1 lakh 2,000. It could be 99,500. Essay around 1 lakh. Huh? I'm just given these figures around, approximate. Okay. Now, if you ever think कि आप इस किस्म के inputs को, and imagine there is a one more video E also, this is also having approximately same value of around 1 lakh. So now if you are giving such kind of inputs to any ML model to learn, please remember such a ML model will produce a biased result. Okay, what does it mean? It will always predict a biased result. Now this means that if I have made an ML model, let's say this is my ML model. Now I'm getting a YouTube video called double A, which is of the similar category of this. Example, you have videos of some stand-up comedians, and this is their kind of views. So you got another stand-up comedian, double A video, and your company has to predict how many views this video could have. So you are giving this video to the ML model, and the ML model is supposed to predict. And the ML model predicts that this particular video double A would probably have 11,000 approximate views. This is a prediction which it has made. But this is 11,000 views after 1 week, suppose. But actually, this is predicted value. But actually, we found that after 1 week, this video called double A had only 6,545 actual views. We will say, okay, no problem. It seems my ML model over predicted. Then after a few days, you gave another video called AAA. And this fellow predicted that your video would be seen for 1 lakh 20 times. But your video was actually seen, this is predicted, but your video was actually seen for 52,000 times. And say, oh my god, again this fellow over predicted. Didn't you realize that this fellow is only over predicting? He's never under predicting. Why? Because the model is giving you biased results, it's come into a positive bias. He has got overfit to the larger values. So whenever your model has higher numeric values, it will always tend to predict towards higher values, and therefore the lower values get kind of ignored. So even if a video is worth for 100 or 200 or 5,000 views, still this guy is going to give a very high view output. So this such a model is useless. No? What is the use of it? So फिर क्या आप करें? आपने स्केलिंग नहीं, अब स्केलिंग से क्या होगा? स्केलिंग से ये होगा कि if I can just clean my board a bit. So what will happen by cleaning by scaling is you will scale this. There's a lot of ways of scaling. There is something called as a min-max scalar or robust scalar and the most commonly used standard scalar. What standard scalar does is it takes the value of x. Imagine this is x. It takes the value of x, so it takes up every row. So this is x1, x2, x3. So I'll put it as xi. It subtracts from it the value of the mean of this, average of this, and divides it by the standard deviation. This is a formula for standard scalar. So every value will be taken, let's say 100 will be taken, according to the formula, that will be 100 minus whatever is average. I don't want to find whatever is average of this. Of course, the average will be close to 1 lakh because there are two 1 lakh values here, divided by the standard deviation.
The one doubt.
Yes, yes, Boomer. Boomer, can you give me 2 minutes? Let me finish with this, then I'll ask for the, I'll allow for the
Okay, sir.
doubts.
Okay,
Huh?
sir.
So, once this is done, you are given your scaled value. The another way of scaling could be using a log transformation, where a log transformation would comfortably take a log of this data. Imagine this. If I take a log of this data, a log of 100 would be obviously 2. I'm talking about log of 100 to the base 10 would be 2. Log of 1000, 3, 10,000, 4, 1 lakh 5, another 1 lakh 5. So if I notice after the standard scaling or after doing a log, my data has skewed. It has been brought down heavily. Exactly. Where are these values 100 to 1 lakh? Where are these values from 2 to 5? So between the min after logging or after transforming or after scaling and the max, the delta which is existing is very low. Na? Delta is extremely very low. 5 minus 2, 3. Your delta is 1 lakh minus 100, 99,900. The delta or the difference is huge here, while here it is much lesser. Okay, so this kind of data is given to the ML model to be trained. The ML model will always predict much closer to the actual, thereby giving us the least value of error. Okay, I hope the importance of scaling is getting clearer. Yes, Boomer, over to you.
Sir, in case the data we are standardizing
Mhm.
for plotting everything, in case if all the data are in a particular range, for example, 100 to 10 to 100, 10 to 100, or 1 to 100, if it is all the data are like that, then also the standardization is
No,
necessary
no,
or no,
no,
na?
no. You can skip it. That's optional.
Okay.
Yeah. Okay. Right. So How are we doing the standard scaling? It's super simple. Friends, there could be some part of the code which is missing in your notebook. The purpose of keeping it out is so that you pay attention on the session and listen to me and code along with me a little bit. Rest is completely coded. So 10% I have removed from there so that you pay attention on your notebook. Otherwise, you just keep watching my video. No, you will not be able to. You will not look at your notebook at all. Okay, so how will I scale? I am loading from my scikit-learn preprocessing library the standard scalar. I made an object of it. ss.fit is being fit over the numeric features because scaling can be done only over numeric features. After doing that, please notice to scale I have to do two things. First is fit and then the next is transform. Both of them form a pair. Fit will learn what is the range of a data. What is it going 100 to 1 lakh or 100 to 500? What is the range? And transform will actually perform the calculation I just mentioned to you. Xi minus mu divided by standard deviation. That is done, transformation done, and in the training features data frame, under the numeric feature names, you are storing your scaled data. Just to prove you things, I printed everything here. I've run the cell. Please wait. Python engine is busy. It's processing. Wait. No error. I forgot to run this cell. Please make sure you run this cell. You're running every cell, huh? Every cell's run button should be clicked step by step as I'm progressing ahead. Don't skip any cell. I skipped two cells while explaining, so I have to run it now again. Please have a look. In my original data frame, I had research score as 80, 90, 100. Now it has become 0.89, 0.73, minus 1.8. This range is much smaller here. There is a range going from minimum 10 to maximum 90, and there is a range going from minimum minus 1.8 to a maximum of 0.96. Delta is reduced, no? Ranges got reduced. Similarly, for project score, was ranging from minimum 10 or 15 going up to highest 90 or 95. That has got reduced to as low as I think minus 1.56 to a positive high of 1.37. Okay, so the delta of the ranges got reduced. Okay, so now Vispita should please help me to tell me, is this entire code given of standard scaling or some code is missing? Yeah, so what code is missing you need to highlight. When you're saying from feature extraction, uh, there is no feature extraction here in this cell. Are you trying to say some other cell is missing?
So please scroll up from the second. Yeah, from here. Yes, this cell. This cell is missing, sir. Get feature and corresponding outputs, outcomes.
Whole cell is missing.
Yes, sir.
So Vismita, be on audio continuously. So the friends, the
Yes,
first
sir.
cell is missing, and I have already punched the code of this first cell. So please, everybody should pick it up and paste it there in the cell and run it. Okay, how many people have ran with this code? How many people have ran with this code should please say yes on a chat. Paste किया आप run कर लो इसे immediately send को. Vishmita says yes. Why Mayura is now gone slow? Mayura करना क्या है? Copy और paste करके run करना है. Why so much time? Please be fast.
We do have this code, sir.
Okay.
List down features. Yes, sir. This
Yeah.
code is there.
Please run the cell. But run the cell.
Yes, sir. Yes, sir. Yes, this whole is missing.
Whole is missing. Okay. So let me give you this whole thing in two parts. First part given. Now giving the second part. Okay. Bismita says done. That means she would have got this kind of an output where the research score and the project score has got squeezed into or has got scaled. What about Mayura or anybody else who is doing along? So this is just a quick read. Before transformation, the range of research score was going from 10 to 92. And after transformation, the range of research score has come from minus 1.8 to 0.96. Even a layman, you haven't to be so educated to actually understand this. Even a layman understands 92 to 10 is having a much wider range. Delta is much higher as compared to minus 1.8 to 0.96. Delta is much smaller. Now, what should you do with categorical data? See, before I talk about categorical data, let me tell you why do you need processing over categorical data. Suppose if I had a categorical data like gender, which probably be having two values, that is male and female. The problem is that no machine learning model can take anything in English as an input. No machine learning model can take English as an input. So you cannot give him an categorical data like grades A plus, B plus, or gender, male, female, or obedient, yes, no, or you neither can give him any text-based data. So anything which is text-based or anything which is categorical in nature has to be converted into numeric. Hey, come on, how will I convert this into numeric? It's simple. We have to apply a technique which is called as, there are many encoding techniques. One of them and the simplest of them is one hot encoding. What one hot encoding does is, It will first find unique values in the gender column. Suppose there were many people and their gender is specified. So out of 100 people who are participating in your experiment, all people, so unique genders of them were only two, male or female. So now the point is, what the OHE or one-hot encoding does is, it makes two columns. First is gender male, other is gender female. It made two columns like this. So in whichever row male is given, it will replace it with 1 0. Whichever row female is given, it will replace with 0 and 1. So in short, if I wanted to give to my ML model, I will not give male. Instead, I am going to give a binary sequence 1 0. And if I wish to give female as an input to my machine learning system, I won't do that. I would give 0 1 as a binary sequence. And ML model is very happy. ML model says, as far as you can give me numbers, I'm happy. I'll get myself trained. Because ML model, I'm sorry to say, doesn't understand anything in any language, whether it's English, Hindi, or Urdu. It doesn't understand anything in any language. So you have to convert your language or text-based data into numeric form. To do this, we are doing right now is we are pre-processing categorical data. अब कैसे करें इसको? बहुत simple है. To do pre-processing of categorical data, we straight away go to a technique called one hot encoding. So pandas.getDummies is getting. So what it's doing is it is going to training features. From the training features, it is picking up the categorical feature names. दो columns categorical feature names के हैं. एक obedient है और दूसरा है overall grade. इन दोनों को लिया. Get dummies is direct method, direct function to apply one hot encoding. So it is हो गया one hot encoded. बस इसको आपने रन किया, complete one hot encoding हो जाएगा. One hot encode होकर data is being dumped back to training features. When I printed it, please see what output have I got. Oh, interesting. It first found, one hot encoding first found how many unique grades I had. So it seems we had 5 unique grades: A, B, C, E, and F. It therefore made so in so many columns. Overall grade A, these are new columns which has been generated by one hot encoding. And obedient were only two unique values, so we got two columns, obedient no and obedient yes. After having done all this, please notice, जो first student है, I will show you once again, he had got grade A. Now because the first student had got grade A, so obviously in one hot encoding, only under the column overall grade A, there will be a 1, rest all other column values are going to be 0. Similarly, the first student had obedience, yes, he was obedient. So obedient Y is 1, rest for all it is 0. Okay, right? So I hope this is going simple. So now again I would request Vismita to please tell me if any code of this is missing.
Yes, sir. This is missing.
Perfect. Thank you, Mayura and Vismita. Please keep guiding like this so that the whole batch is at help. So please copy paste this code which I have given over the chat and please run the cell. And check your output with mine. Take 2 minutes aram se. Okay, excellent going, Mayura and Vismita. Both have already finished this much part. So data pre-processing is done. Now our data is ready. So much of work had to be done. This is a toy data set. Imagine this data set was a big one having 80,000 or 8 lakh records with lots of missing values, lots of nonsense. The cleaning itself would have taken 2 or 3 hours, or even more. And data pre-processing would have taken another 1 or 2 days. So usually we spend a lot of time in data cleaning and data pre-processing. Okay, now what comes next? Next is this, I'm just trying to print the name of the new columns got generated. I'm just trying to print, so what I'm doing is from training features dot columns, I'm subtracting numeric feature names. So numeric features, we never did anything, no? Numeric features were already there. So the new categorical engineered features, that means जो categorical columns थे हमारे, उसको हमने re-engineering किया ना, by doing one-hot encoding. So the new such columns got generated are these many. Just to give you some statistical answer, you previously had only two categorical columns. One was overall grade and one was obedience. But now you are having but now you are having 7 categorical columns. See carefully. 1, 2, 3, 4, 5, 6, 7. You are having 7 categorical columns. This is a very important thing which you need to actually keep in mind. Now this is a toy data set, my friend. This is a toy data set where you are having just 4 categorical features. In reality, you probably would have a data set which is having like 30 to 40 columns or even more. Out of 30, 40 columns, if I have 30 columns, out of 40 columns, let's say if I have 30 columns which is categorical, and if this categorical data is having, let's say, n number of unique values, well, let's say n is 10, then obviously I'm into a model where I have got 10 into 30 into 10, 300. Oh my god, 300 new columns. So usually after one-hot encoding, our number of columns are going to be extremely very large. But that is a requirement, we can't help it. That's the reason when you're performing larger projects, specifically for research work, you do require little high-end machines or server machines or GPU-based machines which are quite expensive. They usually cost you 1 lakh and above. But then that is a worth of an investment. If anybody of you wishes to get more into AI because of your research work or because of your hobby, then you should do that expenditure on your machine first. Okay. Now, step 4 is modeling. Simple. Modeling means you're going to make a machine learning model to classify our data. Now, what we are doing is we are making a classifier called logistic regression. Now, friends, there are lots of classifiers available. Just to give a name of few quickly, logistic regression is the simplest of all the classifiers and is considered as one of the best classifiers. Logistic regression, I repeat, is one of the best classifiers and they're considered as the best for binary classification. So if you are having to do any binary classification like diabetes, no diabetes, COVID positive, not COVID positive, this problem P, this disease P, or no disease P, you should prefer to please use logistic regression because it is considered good. If you have binary classification, usually it gives good performance. Okay, but many a times the data is not of that kind, that it only has 2 classes. Example, if I want to classify fruits by taking their images, Imagine this is a manufacturing plant, a packaging plant for a company like ITC, for a company like ITC, and they want to package, they want to sell packaged fruits. So instead of buying the fruits from the loose market, these guys want to sell fruits, maybe premium fruits like mangoes and apples. So apples could be, there are green apples, there are red apples, there are apples which have got ripe. So, you know, and there could be apples which are raw, which are yet not ripe. So a machine should be able to take a pick of it and should be able to classify whether it's a green apple, red apple, ripe apple, or raw apple. Raw will go to the storage unit. Ripe will get discarded. Red will go to the red box packaging. Green will go to the green box packaging. Simple, and because the prices are different. So my point to you, all of you here, is that this is a multi-classification problem. And for such multi-classification problem, it is preferred to be using, no, logistic regression, no, answer is no. Use other. So other ones are decision tree classifier, random forest classifier. Then you could go for naive Bayes classifier, SVM, support vector machine classification, in which you have many different subtypes which are called as kernel types, which could be multinomial, which could be Gaussian, which could further be as RBF, radial basis function. And there are a few more kernel types also. There are many, the list is a little more longer, but I'm just winding up the list with specifying one more. You could go for XGBoost classifier. Or the list doesn't end. जितना मैंने आपको बताया उतने और भी. Okay, but I'm ending the list. So what I'm trying to tell you is that you have so much choices of so many different classifiers, लेकिन आपने सोच समझकर एक particular classifier को choose किया है क्योंकि आपको पता है कि आपका data जो है वो binary classification mode में है. Okay, अब it's a binary data ना. You are going to either allow the research grant to a student or you will not allow the research grant to the student. दो ही बातें हो सकती है ना. Okay, this is a piece of announcement. My friend Lubna has just shared the attendance link over the chat. So please do the needful also while learning the code further. Okay, so we have just made a model of logistic regression. So after making a logistic regression model, we move further where we are saying logistic regression model LR.fit training underscore features is your original data set in which all the columns, all numeric columns have been scaled and all the categorical features have been one hot encoded, and the outcome labels is recommend, which has two words, yes or no. So see this, you made a machine learning model, actually a classifier model, and you're asking the classifier to fit. So when you say classifier to fit over the data, that means you're asking the classifier to learn. Okay, you're asking the classifier to learn your data. So it's like a child who's learning the data. This is the kind of inputs, this is the kind of output. So the child is learning, the ML model is learning. Acha, if these are the training features, then the outcome level is yes. These are the training features, outcome level is y. ऐसा वो learn कर रहा है. Learn करने के बाद, I just thought I should print the model just to verify. If the model gets printed, that means the model was created. Okay. At many times what we do, that goes into advanced machine learning, where we try to play around with these parameters. So we play around with these parameters to check whether our model is performing little better or not. Of course, by playing around with these parameters, don't expect a model to be chamatkar kuch nahi hone wala, model will have little improvement in it. It may not also have, it may go bad also. It's like tuning a radio. So the radio is normally running at 92.7, but while you're driving, it goes unclear. So you can do little tuning, no? Up and down. That's what we do by using this. This is called hyperparameter tuning. Okay. Now see what I'm doing. Okay. Now my model has got trained. My model says I know which student to recommend, which not to recommend. ऐसा model बोल रहा है आपको. ठीक है. So look at my comment here. Okay. Now I'm giving you some real student data who want to know whether they would be given research grant or not. आप कहते हो कि आपका मॉडल रेडी है, आप कहते हो कि आपका बच्चा पढ़ के आया है, आप मेरे पास उसको लेके आए, मैं एक टीचर हूँ, क्या करूंगा? एक क्वेश्चन पेपर दूंगा, एक टेस्ट पेपर दूंगा, चेक करूंगा, टेस्ट करूंगा, रियली वो पढ़ के आया है कि नहीं. सेम चीज, आप मॉडल तो लेके आए मेरे पास कि भैया मॉडल बन गया हमारा, तो मैंने कहा ठीक है, आओ इधर लेके आओ, सामने रखो, टेस्ट करते हैं इसे. सो आई हैव मेड अ डेटा फ्रेम. As you could see, in this new data frame, I have kept some new data. These are some kind of new students who have come to me, applied to university. Ninad, Alex, Fayaz, Sejal, and Vijay. This was the grades reported by their previous university about their research work. Now they want to do PhD with you. This is their obedience score, their research score, and their project score. ठीक है. And whether should you give them grant or not is a question mark. शायद वो आपकी यूनिवर्सिटी की हो. So I'm sure the cell which is having new data is there. Please check. Mayura, Vismita, this cell code is there or not? Please check.
Sir, the previous cell data is not there.
What is not there of this? Everything.
Sir, from get list of new categorical features. Yeah, from here, right. This we are not having.
Okay. Take 1-2 minutes. Copy this from the chat to your cell and run it first. Done, no? Yes, Vismita, your audio is on. Done, no? Till this point?
Yes, sir. Yes, sir. Yes, sir. Till that we have done. Here, few data, few lines of code is missing.
Like what?
Yes, sir. We do have this code.
Okay.
sklearn model we do have.
So Mayura is requesting to share the full code. So can I do that? Should I share it still with the comments?
Okay, sir. Yes, sir. Yes, sir.
This is the first half of the code. Fit the model. Second half of the code with the comments. Yeah, Vismita, I'm waiting for Mayura to acknowledge. Mayura is done. Fantastic. So both of you are because coding along. Right. Okay.
Yeah, cell. This coding is there. This coding is there.
Okay. Can you just run this cell so that you should also get the same output? I'll wait.
Yes, sir. Yes, sir. Yes, sir.
Perfect, both of you. Very good going. Okay. Now, friends, what I'm doing next. Friends, what you got right now is some new data. बट आपको ये बात मतलब फील हो ही चुकी होगी आप सब लोगों को कि this new data is having overall grade in the form of categorical data the way it should be. Research score in numbers from 1 to 100, project score numbers 1 to 100. But was the ML model trained on the research score like 78 or 98? I don't think so. Was the ML model trained on the overall grade like F and C and A? I don't think so. Your model was trained on one hot encoded, that is binary format of overall grade. It was trained on scaled data of research score. It was that. That's right. So you have to be very careful. I told you, I'm again repeating, that an ML model training is like training a small kid at your home who is probably in third or fourth standard. उसको आपको बहुत carefully हर चीज सिखानी है. आपके acts, आपके deeds बहुत carefully होने चाहिए उनके सामने, because they will catch up very fast. ML model is exactly like that of a kid who is third and fourth standard. You have to be very careful of what you teach him or her, what you speak with him or her. You have to be conscious. So the point now is that if your ML model was trained on scaled research score, scaled project score, and one not encoded data for obedient and overall grade, then I'm sorry, you can't give this data. I'm sorry, you can't. So what should I do? Do the same thing what you did on the original data. Do the same data pre-processing over the test data also. You have to do it. That's a part of the machine learning process. So we are taking our new data frame feature names, giving it to the prediction features. We had already made the object of standard scalar above, no? You remember, no? So I'm reusing it. Why to make unnecessary objects? So you already have the object of standard scalar. You are using it to transform the numeric features. You already have the knowledge that the categorical feature names are stored in this variable. So you're applying get dummies to do one-hot encoding. So now your new data that is for testing purpose has also come in the same format as the training data was. See, the test data has come in the same format. All the research score and project scores have been scaled and grades have been carefully one not encoded. So grade A, B, C, E, and F were not encoded. Obedient, no, and yes were not encoded. Okay. So please apply at your end also. If anything is missing, Vismita or Mayura will
This is
highlight.
there, sir. This code part is there.
Okay. Please run it. See, do you get the same output?
Yes, sir.
I'll wait.
Yes, sir. Yes.
Okay, Mayura says done. Right. I think Vishmita also would have done by now. Mayura, your question is not so clear to me. So you will have to probably come on audio and explain.
Hello, sir.
Yes, hi Mayura, good morning.
Yeah, hi, good morning.
Yeah.
Sir, here at the end, it shows showing only four columns. That is research score, project score, and then it is showing dot dots and last
Uh-huh.
obedient N,
That
obedient
is
Y.
no, that is because of collab. Collab truncates it.
Okay,
Collab, if you have too many columns, so it will truncate. It will not show all.
okay.
It is
So,
that is you can't help it. In collab, it will get truncated.
Okay. Is there any possibility to just see the result like your screen?
No, you will have to print only that respective columns, few columns at a time.
Okay.
If you're printing the whole data frame the way I have done, prediction features, the whole data frame, then the truncation is compulsory. It will happen in Colab. Can't help it. Then you have to print only from the data frame prediction features at a time. You only print 2 or 3 columns. Then it will be visible.
Okay. Okay. Thank you, sir.
Yeah. Even in Jupyter also truncation will happen. Now I have got 8 or 10 columns, but if I had 80, 90 columns, it would have truncated. Okay. Now we come to the last part of the ML, with so much of hard work which we have done right now, made the ML model, did the data processing, trained the ML model, then we took the new data, registers data, we did data pre-processing over it also. So we have our complete feature set ready for all the new students. Let's put our model to test and get the predictions with regard to grant recommendations. चलो देखते हैं. So I'm telling my model, can you please predict using the new data? He will say okay. And whatever his predictions are, which could be either yes or no, has been dumped in the variable predictions. So what I'm doing is, I'm copying those predictions into a column called recommend, which is a new column which I'm adding in my data set called new data. Please remember, my new data frame never had a column called recommend before. It only had the columns name, overall grade, obedient, research score and project score. यही था ना. स्टूडेंट सॉरी जब आपके यूनिवर्सिटी में अप्लाई करेगा वो सॉरी कहेगा मुझे रिकमेंडेशन मिलेगा कि नहीं मिलेगा, वो सॉरी बोलेगा. आपको डिसाइड करना है. आप डीन हो यूनिवर्सिटी, आप हेड ऑफ द डिपार्टमेंट हो, आपके डिपार्टमेंट में वो स्टूडेंट पीएचडी करना चाहता है, आपको डिसाइड करना है कि आप उसको ग्रांट करना चाहते हो कि नहीं करना चाहते. सो न्यू स्टूडेंट रिकमेंड कॉलम आपने बनाया और प्रेडिक्शन उसमें उठा के रख दिए. चेक कीजिए, मुझे आंसर ऐसा कुछ आया. इट सीम्स कि आपका मॉडल निनाद को, एलेक्स को और विजयन को रिकमेंड नहीं करने वाला, और आपका मॉडल फयाज को और सेजल को रिकमेंड कर रहा है. ओके. नाउ this recommendation which is given is a kind of a helping hand for the dean, for the professor, for the head of the department to decide approximately how many students. See, there are 5 now which you can actually view and decide. Tomorrow if you had 500 applications, then what will you do? You'll keep scanning each and every application's resume and biodata to check what projects he has done in the past, what has been his past record. Is it possible? No. So what you will to say, you will call upon a data entry operator. You will tell the data entry operator, come on, for all the 500 applications, make an Excel sheet for me. You will just pick up the resume and feed into Excel sheet. What you will do as a professor, as an AI person, as an ML engineer, you will write this code. What I have written on the board here. Of course, this code can be made much more polished. You can add many more features here. So you will write this code and you will take your data of the Excel sheet and actually find out how many people are probable candidates. Now, those people who have been predicted yes by your model can actually be scrutinized by you as human. So out of 500, if you get 50 applicants which your model is saying yes, you may pick up those 50 applications physically as a head of the department, as a professor of your department, and scrutinize out of those 50 people, which 10 people or 5 people do you think you should be giving the research grant. As simple as that. So you get a fair idea. Okay, this is what it helps you, right? So this is called technology as an enabler. So MN is actually an enabler. It doesn't replaces you, it helps you to do better work. All right, Ms. Peter, if any part of this code is missing, please highlight.
Sir, it is there.
Okay, okay, very good. Please run
I
and
got
tell
the
me
answer.
you got
Yes,
the
sir.
answer. The
I
answer
got
is
the
same.
answer.
Is it same as mine or could be different also?
Sir, like you only we got same.
Ditto same. Okay. No, at times people get different answer. At times people get Alex also is usually recommended because Alex is on the borderline actually. In fact, if you look at it, Alex is a misclassification. Alex is said no for recommendation, and Fayaz is being said yes for recommendation. But if you look at it, every angle, Alex is having a better score than Fayaz. So I can see there are two misclassifications here by the model. Fayaz and Alex are misclassifications. Now, what is a misclassification? See, what logistic regression basically does is it finds the best separating line, not best fit line. Huh? Don't get me wrong. It finds the best separating line. With the best separating line, what happens is there are some points here and there are some points out over here. So now there is a possibility that the points which are over here, so assume this is the points which are like given the grant and this is not given the grant. So there are some points which could be misclassified out over here. So if I just a second, I just color them in a different way. Hold on. Otherwise it will be confusing for the viewers. Just give me a second. Okay, so I have got two set of points here. One set of points is not going to be given a grant. Another set of people who are going to be given a grant. Now the point here is that if there is a person who is probably on the borderline like this, so he is coming in the category of actually being given a grant, but this unfortunately the best separating line this position में खड़ा है, वो इस point को non-grant category में डाल रहा है. So this point rightfully by characteristics is on the borderline between the two and therefore he got misclassified. So this is a case of misclassification. The lesser the misclassification, the better the classification model is what you have made. But this model is not a good model because it has got two misclassifications. I can see Fayaz and Alex, or at least there is one misclassification for 100%. Alex is 110% misclassified. See, by human intelligence you can see. Alex grade B better than Fayaz. Alex obedient better than Fayaz. Alex 78 more than Fayaz. Alex higher project score more than Fayaz. And what reason is there that Alex has been rejected? No reason. So this is a clear-cut case. I have no problems in saying that you may give Fayaz also has been recommended. It's okay. Fayaz and Sejal has been recommended is absolutely correct. But if Fayaz and Sejal has got recommended, by all means Alex should have been recommended because Alex is better than in his project score and research score than Fayaz. So that's what I wanted to say is that there will be misclassifications in your data as well as in all cases misclassifications will happen. Okay, right? So I hope this experience of starting an ML model, what I did was actually all the steps: data preparation, scaling the numeric features, doing one-hot encoding over categorical features, then model fitting, where we made the ML model logistic regression to fit over the data. Then we did model evaluation, in which we didn't do model evaluation, to be honest. Model evaluation will tell you what is the kind of number of misclassifications by printing the confusion matrix or classification report or accuracy. But in this case, it is not necessary because in this case, it's a human operator who's going to use your data. So even if he's being told upon after the model output, so instead people are going to get recommended or not, it is a human decision to decide now कि उसको recommendation करना है कि नहीं. So these two phases, of course, were not done. Yeah, but your answer to the question is hyperparameter tuning. So we could do tuning of the parameters of logistic regression so that such kind of misclassifications are reduced. Although they will never be eliminated. Some misclassification is always going to happen in a classifier, but it can be reduced. Yep. So any other questions? Please be frank and free. There is no hard and fast rule कि आपको इस 2 घंटे के टॉपिक पर कंसाइज रहना है. You can ask me anything whichever you wish to ask. You can come to audio or you can ask me on the chat, whatever you feel comfortable. I'm again giving you the freedom. Don't restrict yourself to this topic. Anything related to ML or AI you want to ask, please come forward.
Sir, the hyperparameter tuning that you were saying, in small example, can you tell me, sir, or
Yes.
show?
Show तो possible नहीं होगा ना, because I have to then share the notebook and code and all that stuff. But I can tell you to you here. Okay, so notice this, there is a penalty factor. There is a penalty factor by default which is called L2. So there is something called as regularization which you can do over logistic regression. So regularization basically means that you are going to add a small amount of bias. You will add. In fact, people try to reduce the bias. So ML model usually tries to reduce the bias, but no, I am adding a little more bias to reduce the variance in my data. Now, when I am going to actually add the bias, how do I do that? Now, to add the bias, you are having some regularization techniques. You could apply ridge regularization. You could apply lasso regularization, or you could apply a combination of these two, that is elastic net regularization. As regards ridge regularization, it is in short called as L1, lasso, sorry, ulta bol diya maine, ridge L2, lasso L1, elastic net is elastic net only. So this is one way in logistic regression where you could apply. Now what will they do? What is their effect? Their effect is something like this, that let's say that you have found that this is the best separating lines position. Let me put it this way. Yeah. So let me put it this way, that let's say that this is the best position which your logistic regression is found for the best separating line. What all these regularization techniques do? What is going to happen if I add a little more bias? Either this line is going to be little shifted up or little shifted down, or its angle is going to be changed like this. So when you are able to tweak the line, I'm not moving the line from here to here or from here to here. No. I'm just moving the line a little bit up or little bit down, or probably changing the angle at which the line is made, thereby getting a more effective linear separation between the points. So if we were to have points over here, and there were some points which are very close to the line, then some of these points would actually get classified in a different category or a different class, because some points which are very close will get influenced, no? And that is what reduces the misclassification. Misclassification बुरा होता ही इनके वजह से है जो points separating line के बहुत close होते हैं. तो अगर इनमें से ये लाइन जो बहुत क्लोज है, इनको अगर मान लेते हैं एक सेकंड के लिए कि अगर आपको फ्रीडम मिलता है कि आप इस लाइन को ऊपर नीचे कर सकते हैं, तो अगर आप कर लेते हैं तो ऑब्वियसली you are able to. For example, if I say that these 2 pointers are actually black, but they have come in the green category. So if I allow you to move this line a bit low, somewhere out over here, of separation, then these two black lines, black dots will obviously go into the black category, and the number of misclassifications are going to get reduced. Right? Are you able to get me on this?
Yes, sir.
Right? Yeah. Shakil, your question is a very vague question. You do not know about this thing. How to obtain the best fit model in deep learning is a wrong question. Sorry to say that it's a wrong question. Probably need to go through a formal training, so then you'll understand. So, you deep learning. When you're doing deep learning, you're basically doing the same thing, but you're running your model for a number of epochs and for appropriate batch sizes. That's it. So it learns over a period of time.
Sir, multicollinearity is a very big problem. How to reduce that?
What is multicollinearity?
Because
By
the
the way,
multiple data points will be coincide in one particular means that the same kind of data will be repeated in the data set.
no, no,
So
no, 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 no. So let's say that you have 4 columns. If the column A increases and correspondingly if the column C also increases, so both of these columns which are correlated to each other lead to collinearity and they belong to your feature set. So in such cases, it's very simple. It's the simplest thing which you can do. It's a very simple problem. Collinearity it's not a big problem. It's a very simple problem. You have to drop one of them. So which of the two features will you drop? Totally depends upon which feature has the highest coefficient to influence the outcome target variable y, and that's what regularization does. So if you look at your ridge regularization or lasso regularization, what it does basically is it finds which particular values or which particular features first of all are collinear, and which are collinear, either you can ask the ridge or lasso to drop it, or you can even take a manual decision that okay, now these two are collinear and you could keep one of them and drop the other. Now that depends upon kiska coefficient on the higher side hai. So what the regularization technique does is it reduces the coefficient value in such a way that if A's coefficient is reduced and also C's coefficient is reduced, and if A and C are collinear, one of the coefficients will come to 0 or almost to 0. अब आप खुद सोचिए किसी का कोएफिशिएंट अगर 0 आ गया तो वो फीचर तो आउट हो गया. किसी भी फीचर का कोएफिशिएंट अगर 0 आता है, and let's say my equation of my line is y is equal to m1 x1 m2 x2 plus b, then m1 m2 are my coefficients. If I bring the coefficient m2 to 0, then what is the influence of x2? It's not there at all. Why this happened is because x1 and x2 were found collinear by the regularization technique. So the lasso regularization technique reduces the coefficient of the collinear parameters to 0, due to which those parameters are out. Now your model is reduced to y is equal to m1 x1 plus b. It's solved. So collinearity is not a big problem. It's a simple problem, which can be solved by regularization.
thank you, sir.
Right? Okay. Right. So I hope I could answer some of your queries, and you had this application of Python in the FDP3 for automation and or touch upon for ML. Why we touched upon ML is because in case of the near future, if Sabarmati College gets another FDP in the series of data science, AI and ML, then we could probably progress in that direction. But this notebook would have been the starting notebook, and we would have progressed on higher up to solve the higher up problems. Okay. Right. So from my side, I stop here and I'm giving off the control to Samreen or to Lubna.
Sir?
Yeah. Yes. Is it?
Sir, I have a doubt. Can I ask?
Is it Mayura? Yeah. Please
Yes,
go.
sir.
Yes. Please go.
Uh, uh, My question is, sir, every time we need to check manually about the misclassification of the data, and what to do if we have a large number of records.
We haven't to check manually. Who said we to check manually? Nobody will check manually. You can go ahead finding the accuracy, print the accuracy score, uh, uh, print the confusion metrics. Both will give you a clear-cut indication.
Okay,
And if your data is imbalanced, then accuracy score will not be an appropriate parameter. You should probably rely on F1 score. The higher the value
okay,
of F1 score, the better your data is. Because F1 score is a harmonic mean of two parameters. One is precision, other is recall. So instead of looking at precision and recall, look at F1 score if the data is imbalanced data. And if the data is balanced, look at accuracy score. So
okay,
accuracy score is a positive performance metric. The higher the accuracy score, the better it is. And as regards F1 score, again, higher the value it is towards 1, the better it is.
okay, sir.
Okay, yeah. So one line code just to print it. That's it. और कुछ नहीं करना है इसमें. Okay. So I give my control off to summary.
Yes, sir. Any participants has any doubt? So they can ask Rocky, sir. Okay, sir, then we would end the session here. And sir, it gives me immense pleasure to thank you for conducting hands-on session for all our three FDPs and making it a momentous for us. And thank you, sir, for playing the vital role in cooperating through all the three FDPs and bearing with us. We look forward for the furthermore interactions with you. And
Sure.
thank you once again, sir. Thanks a lot, sir.
Thank you everyone. So
Yeah,
they have to
thank you,
all
sir.
come back at what time to inform them?
They have to come back at 1 o'clock.
At 1 o'clock.
1 to 3 o'clock, they have Surendra Rathod, sir, SPIT staff for National Education Policy.
Oh wow,
So we
interesting.
request all the
And
participants to be there connected with us at 1 o'clock.
yeah, and that is also going to be with the validatory function, right?
Yes, sir. After that, at 4 o'clock, the validatory function will start up to 5:30.
Fantastic,
Okay.
fantastic. Very
Sabrine,
nice.
Thank
please
you,
tell the
everybody.
participants that session 1 to 3 is compulsory because as per AICT we need to conduct this 1 2 hour for NEP and they have to be there. So please, participants are requested please to be there for that session 1 to 3. Surendra sir, Rathod sir.
And one more thing, friends, and let's inform you that Rathod, so the way he communicates or the way he delivers the sessions is very interesting. So even if you're attending an NAP session, not coding and all that stuff, you're still going to enjoy it. Trust me, and plus knowledgeable also. He's very good in extracting points and highlighting them. So he'll be fruitful, right? Yeah. Thank you, everyone. Bye bye.
Rocky sir,
Thank you, sir.
thanks a lot.
Yeah. Thank you, ma'am.
Thank you very
Thank
much.
you.
Yes. Thank you.
Yeah.
Bye.